Good evening and happy weekend. This weekend we are going to do 6.4 and 6.5 because on Monday we're going to do those in class. So 6.4 and 6.5. Let's get started on page 318. Consider the equation. So we're considering this equation right here. Keegan says that to tell if the expression in an equation are equivalent, not just equal, you just need to evaluate each expression for the same value of x. Evaluate the expression on each side of the equal sign for x equals 2. So what that looks like is just putting a 2 wherever you see an x. So you don't simplify the equation yet. So you put a 2 wherever you see an x, and then you solve. So you get negative 4 times 1 equals negative 4. And that's for this first part here. So then we want to know, does it equal this equation? So then I put a 2 where I see the x, and do that, and I also get 4. 25.6 plus 21.6 equals 4. I'm a little nervous about that. I think this is supposed to be negative 21.6. Our dear book has some problems these days. Alright, so are they equivalent? So one is 4 and one is negative 4, or one is negative 4 and one is 40 something. So are they equivalent? No, since the left side is not equal to negative 4, like the two sides aren't equal, these expressions are not equivalent. So you can write a statement adding the real deal, the problem it gives, or this new one here is what I want. Sorry about this silly book. Okay, Jasmine. Let's go ahead and skip number 3. Let's keep moving on since that was a silly question. All right, next page. All right, let's move on and do number 7. So it wants us to graph both. So in your graphing calculator, you would hit the y equals button. Just kidding, hold on. Yes, the y equals button. So type in your calculator y1 equals negative 4 parentheses 3.2, and you can even put a multiplication sign here if you want between the 4 and the parentheses so your calculator knows. 3.2, where there's an x, you can put x. The x key, if you have the graphing calculator, you're going to do second, the little blue button, and then the x. Actually, no second. Oh, my Lanta. I'm sorry. Okay, the X is under the word mode. So next to second is the word mode. And under the word mode is a XT, etc. So you'll hit that button and it'll choose an X. So put both this into Y1 and this into Y2, and then your graphing calculator, here's the screen, the button right below the screen all the way to the right. This button says graph, so then you'll hit graph. Try that now and then sketch the image that you see. All right, so you should have got this. And so that the lines are different, if we look at 8 and 9 on page 320, are the expressions equivalent? Clearly the graphs are not the same, and so the expressions are not equivalent. And then, so which method is more efficient? So it just depends. You write which one you think is more efficient. I think evaluating for the specific value is more efficient in this case, but with the problem being silly, we didn't get exactly what we wanted, but you can always graph two lines and see if the lines are the same or cross at a certain point to get different data. Okie doke, let's try problem 2 and make sure the book knows what's going on now. Are these equivalent? So we have these two equations and we're evaluating for x equals 1. So wherever you see an x, you're going to put a 1 in. So you'll solve for the left side and then you'll solve for the right side and you'll see if they're equal. Do that now and press play when you're ready. Both sides equal negative 29 and 67/100, so these are equivalent. So let's move on. See what that means. Next page. All right, we're going to move on to number 2, but before we do that, if you wanted to put those two equations in your calculator and see what happens, that might be kind of fun. All right, let's move on to the next page and try number 2 and press play when you're ready. All right, here we have number 2, and I say yes, they are equivalent. I didn't give you an x, all I did was simplify, so they both equal negative 10x plus negative 2 1/4. So they're equivalent, and then I still didn't give you an x. You could put like a 1 in there or a 3 and just test it out. You'll get the same answer since it's the same equation. Number 3 wants us to graph it and compare. Well, it's the same equation, so we should get the two lines the same. So on 3, I want you to graph this equation on your y equals, and then graph what you see. And press play when you're ready. And they do lie on the same line like I just showed you. So there you have it, that they're equivalent. All right, what about these? Are they equivalent? Let's skip number 1. And I want you to try number 2. So go ahead and try number 2 now. Skip number 1 and try number 2. So I want to know if these two equations are equivalent. So simplify those as far as you can and press play when you're ready. All right, we should have got that they are not equivalent. I also want you to do number 3 on the next page. So try number 3 on the next page. Simplify and then graph so that you can see if they're equivalent if they lie on the same line. So do number 3. Do number 3 on page 323. So 323, try number 3, and then we will be done with 6-4, and then get ready for 6-5. 6.5, it's time to justify. All right, let's be on page 326. All right, one method for verifying that algebraic expressions are equivalent is to simplify the expressions into two identical expressions. So let's look at this example problem here. We have the first step is given, so we were given all this left side, and then we can cross reduce and simplify using the distributive property of multiplication over addition. Then we can multiply, so multiply the two together to get this, and then we use addition, and yes, they are equivalent. So press pause if you need to and take in how we simplified this left side to show that when you simplify it, it does in fact equal the right side. All right, and then let's turn to page 327 and try some of these justifications on our own. So let's turn to page 327. So we have 1, use an operation or property. So remember all our distributive properties that we have, multiplication over addition, division over addition and subtraction, all that we've been studying, and you can look back through your book if you need to remember what those are. All right. So number 1 here, normally always the first step is just the given. So we're trying to say that all this jazz here on the left is equal to this right side. So I start with the left side and I say, okay, it's given. So then what could I do as part of my simplifying process? So the next step we could do is using the distributive property of multiplication over addition. I can do -4 times -3 is a positive 12. And 1 times x is an x. So -4 times -3x is 12x. Then I have -4 times 8, which is -32. So I would write minus -32, or minus -32 actually means plus 32. Another way you could look at this is if you change this to plus and negative. Remember, you can always keep, flip, change. It doesn't hurt anything. -4 times -8 is a positive 32. So now you have a plus sign here, plus 32. And then I just change this down here to plus negative to kind of make you see that a little better there. So then the next step we could do is we're going to combine some like terms. What do we think? commutative property of addition. So see how I'm grouping together the x terms and the numbers here. So 12x plus negative 4x is a positive 8x, 32 plus 8 is 40. Addition of like terms, yes, they are equivalent. So I want you to try the next one. We just did number 1a. There's a number 1b. Yes, it's given first. So I want you to do 1b and press play when you're ready. All right, so you should have just tried 2, and you can check your answers here. Not 2, I'm sorry, B, 1b. All right, so, and no, they're not equivalent because when I simplified down, I did not get that the two statements were the same because this is a 2 and this is a 3. So on the next page, we have letter C. Don't worry about doing letter C. Just if you want to see the answers here, you can kind of look. You don't have to fill out your book, but just if you wanted to take a minute and pause it and kind of review and make sure you know the different justifications. So don't worry about letter C. All right. And number 2, also we're not going to worry about number 2 either. So you don't have to do that in the book, but I am going to show you just if you want to stop and think about the different properties. Number 2 does it backwards, where you have to like show the math, but it gives you the justification. So make sure you study your justifications and know the different ones that you can utilize. Okay, and then letter B, I'm going to show you that one as well. Also, don't worry about doing letter B. But here's how to do it just so that you know how to work the backwards way and do the math when it gives you the justification. We are going to do number 3 and number 4 starting on 331. So any of that other stuff in between you don't need to do. You're welcome to try if you need extra practice. So let's get on to page 331 and try number 3. So now we're going to still simplify, but I didn't just have the left side to simplify. I need to simplify both sides and then compare if they are the same. So you can start with the left side or the right side. I started with the left side. You just rewrite the equation as you see it, so -3, etc. And then you say given. So this is a proof, by the way. We are proving this with our properties and we are simplifying it. The next thing we would do is the distributive property of multiplication over addition, and so on. So I want you to do the left side, do all the steps that you can do, and then do all the justifications. After you do the left side, do the right side, and then compare if they're the same. So go ahead and do that now and press play when you are ready. All right, you should have gotten -12x plus 159 and -9x plus 159, and you can check your justifications, etc. And pause it and take some time if you need to. So are they equivalent? No, they're not equivalent. So this is number 3 on page 331. I want you to do number 4 on page 332, and we can compare and share those with a neighbor tomorrow. I hope you have a good weekend. Thank you for your time, and we'll see you on Monday ready to do classwork worksheet 6.4 and 6.5.